For this presentation, I want to talk to you about two subjects which always seem to come hand in hand: fraud and tomatoes. Hello everyone, my name is Luís Flores and I worked with Abaco Group, an Italian company working in IT solutions for agriculture all around Europe. And my project was about using data science to streamline agricultural inspections. But why is this important? Well, every year, the European Union devotes 38% of its budget on agriculture. And of this rather sizable chunk, 40 billion euros are directly spent on agricultural subsidies. Now, if we want to give subsidies to farmers, the farmers first need to declare the crops that they are growing in their parcels of land, but of course they actually also need to grow these crops. The problem is that some farmers declare that they are growing crops which in fact do not exist. And if these farmers try to ask for subsidies for these non-existent crops, they are committing subsidy fraud. Now, currently, on-site inspections are the default monitoring option to avoid these situations. But these can be slow, costly, sporadic, and in many situations are not even performed at all. And so we could save millions of euros in auditing costs or undetected fraudulent claims if we could automate this inspection process. And this is where satellites come in. Satellites map the Earth's surface and acquire images of cropland areas. And this information from satellites can be matched to the declared land parcel information used or associated with subsidies. Now, in an ideal world, we would like for these images to have very high resolution. The problem is that in reality, these monitoring satellite images have very low spatial resolution, but they can still be quite informative because of a clever trick. So essentially, the information from satellites is reduced to a single number, a vegetation index, which measures the amount of chlorophyll in the terrain, called the NDVI. And when plotted over time, the NDVI form time series, which inform us of the crop life cycle and thus form a unique signature for each crop type. Now in the slide, you can see an example of an NDVI time series for a single agricultural land parcel over the period of a year, and you can see that there were two crops growing over the year. So for my initial fraud detection system, I was asked to focus on the recognition of tomato crops in Malta. And to do this, I had available 300 labeled NDVI time series containing known tomato crop signatures, as well as 4,000 other non-labeled cropland NDVI time series. So to actually start building this fraud detection system, I first had to train a classifier capable of recognizing tomato crops. And to do this, I needed a training set. So what I did was split my labeled NDVI time series into fixed size windows and then collect the windows containing the known tomato crop signatures. I then used this training data to train an outlier detection classifier called a one-class support vector machine. And what this support vector machine does is it finds a decision boundary that best encloses the training data. And then I can show this classifier a data point or a tomato NDVI spectra time series that it hasn't seen before, and it correctly recognizes it as a tomato. Whereas if I show it any other type of crop signature, it lets us know that it's actually an outlier. So remember that my test data set was comprised of NDVI time series, which contain more than one crop per year. And so what I did was I implemented a moving window, which uses my outlier detection classifier to scan the NDVI time series and inform us of the periods where tomato was likely growing. So in this example, I'll let my classifier scan the initial region of the year, and it has informed me that it couldn't find a tomato crop during this period. But then, at the end of the year, the classifier recognizes a tomato crop and lets us know that if a farmer had declared that he had been growing tomatoes in this time of the year for a subsidy purpose, he was being truthful and deserves his hard-earned subsidy. So, in terms of performance, my classifier works quite well, given the limited amount of data that was available. It picks up on 90% of tomatoes and outliers, but more importantly, This approach will be the foundation for a more extensive detection system to combat agricultural subsidy fraud and pave the way to automatic agricultural monitoring, which can save millions to the European taxpayers. Thank you all.